All right, we got ambiguous case triangles. This one's going to be quite a long one and a little bit abstract, this video, just because of the ambiguous case. Now, ambiguous means three things can happen. It can mean that when you go to solve this oblique triangle, that actually no triangles exist given the specific information, whatever angles and sides are given. You could have two triangles with the same information. You'll see how that works out. And then you could have just one triangle, but then, like I got written there, it's not really ambiguous then. But how do you know if it's ambiguous? Well, you don't really know if it's ambiguous. You've got to check if it's ambiguous. So I always use this idea right here, and this is important, okay? So if you ever start solving an oblique triangle with the law of sines, finding an angle, then you would check for if it's ambiguous case triangle. So if you started an oblique triangle question with the 180 rule, it's not ambiguous. If you started with the law of cosines, it's not ambiguous. If you started with the law of sines, finding a side, it's not ambiguous. It's only law of sines when you're finding an angle, the very first step, that you would check for ambiguous case. So I'm going to jump ahead, I'm not even going to go to the questions. I'm going to go straight to the unit circle. Here's a unit circle. You don't learn this, how to fill this in until grade 12, but you have to kind of know the basics, okay? So all these ordered pairs, you see this ordered pair, this ordered pair, this ordered pair, all the way around the circle, okay? I might as well go with these ones too. There you go. And you can see 180 degrees. Okay, so on a unit circle, all angles are measured from 0 degrees going this way, all positive angles to there. Now you can see 0 to 180. Well, triangle's only 180, so we only use that half of the unit circle. Now you can also see over here that the y values of those ordered pairs are our sine values. Now you should notice something about all the y values. Positive, 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 positive. Okay, so they're all positive, which makes sense. Now, the other side you should notice is this. For instance, let's look at this one. Root 3 over 2. So our sine is root 3 over 2 there. But our sine is also root 3 over 2 right there. And if you notice, there's two angles. So that means for every sine that you get, there's going to be a second angle that has the exact same value. Okay? Now, the trick there is to find it is you just take 180 minus your first angle. I'll put a first here. And that gives you your second angle. Okay, so whatever you get for your first angle. So for instance, if you put into your calculator the second function sine of a half, your calculator is going to tell you 30 degrees. Well, to get your second angle, you just take 180 minus 30 in. You'll get 150, and you'll notice, sine was 1/2 there. Okay, so this is the very basics of it. Okay, you won't see me draw this out, but the whole thing, you'll see me draw something related to this. Now, before I leave this page, you'll notice A means that all trig functions are positive, so sine, cos, tan. You'll notice over here, this S means sine, all the sine ratios. So the root 3 over 2, the root 2 over 2, the 1/2, they're all positive. Every other trig ratio would be negative in there. So your cos and your tan, for instance, okay? Again, we'll come back and we'll beat this up in grade 12 a whole bunch. We just need to know that sine has two angles for every positive, and every negative, but every positive ratio under 180 will have two angles, okay? So let's go back here and let's start solving these. The steps are the same for solving oblique triangles. Nothing changes, okay, at all. So I go through my thought processes. Okay, here, I need little c. Here, I'll do this in a different color. I need little c, I need angle A, and I need angle C. So I go like this, C1, A1, C1. And the reason I'm doing that is because when I look at the question, I see a corresponding side and angle, and I see side A with an angle A. So that means I'm going to have to start with the law of sines, finding an angle. So it could be ambiguous. So I'm going to do a solution square where it could be ambiguous here. Whoops. Look at me. Learning to write. Just like so. So I don't know if there's two triangles, but I'm going to set it up as if there is two because of our first hint there of if I start with the law of sines, finding an angle, it could be ambiguous, which means I could have two triangles. I could have zero triangles. We don't know yet. All right. So I'm going to start with sine of A over 12 equals the sine of 48 over 15. I'm going to get the sine of A equals 0.595. So I got a second function that, so inverse sine. And I get angle A1 is equal to 36.5 degrees. Okay, so there's our first angle, 36.5 degrees. Now, remember this guy over here, 36.5 degrees. I am going to throw it on here like so. Okay, so there's our 36.5. That means 180 minus it is going to have the same y value. I'm going to draw this over like this. Same y value as whatever angle's over here. Okay, so there's another angle with the same information. So that's pretty straightforward. So I'm going to say A2 equals 180 minus 36.5. So A2 equals 143.5 degrees. So I'll go put that in there, 143.5 degrees. Perfect. But now, to find that C angle, we know that we can use the 180 rule because we've got angle B and we've got angle A. So angle C1 is the 180 rule. Now, this is different than how we found A2 because A2 is just 180 minus the one angle because of that unit circle. The angle C1, we're using the 180 rule of triangles. So 180 minus 48 minus 36.5 angle C1 equals 95.5 degrees. 95.5 degrees. And real quick, just looking at the second box here. Remember, now I'm using A2 for my C2. So the 180 rule, if you look at angle A2 and you look at angle B, 143.5 plus 48, well, that's like 191.5. That's bigger than 180 degrees. So right off the hop, because my angles are already more than 180 degrees, I know that this triangle does not exist, okay? Because the angles can't be more than 180. So that's one way you tell if a triangle is ambiguous. If the angles, or not ambiguous, is if the angles of your second triangle are more than 180. So that's straight up. Easy. So the angles don't work, can't be a triangle. Just X it out and move on. So let's go find little c. Let's finish the question. So c over sine 95.5 equals 15 over sine of 48. Side C equal 20.1. So there is situation. So this triangle ended up not really being ambiguous. We had to check for ambiguity. And you notice we did get a second angle off the hop, but it wasn't an ambiguous triangle. So let's go do the next one. This one here. Let's see if this one works out. So same thing here. I look at it. I got a corresponding sine angle. To find an angle C. Here, I'll go like this. Angle C is what we're looking for. So I'm using the law of sines to find an angle. I got to check for ambiguity. So we're looking for little a, angle A, angle C. And I'm going to do the second solution square just so I I don't even think about trying to figure it out first. I just do this because I don't want to forget. Okay? So, let's go do the work. We got sine of C over 20 equals sine of 50 over 17. Sine of C equals 0.901. Second function sine that one, or inverse sine. So we get angle C1 equals shift 64.3 degrees. So 64.3 degrees. Perfect. All right. So now, same thing. We know, here I'll jump over to the unit circle again. At 64 degrees, we'll just pretend it's right there. There's our sine. Our y value would have another angle right about there. That would be our second y value. Second angle, that would be the same. So if I take the 180 rule here, 180, not the 180 rule, the unit circle 180 to find that second angle. I don't know how to word that, but just to find that second sine angle. C2 was going to equal 115.8 degrees. Now, if you want to quickly check, all your first angles have to add to 180, and all your second angles have to add to 180 for a triangle to exist. So I can look at C1 right now, this guy, and my given angle B. Yeah, I can get a third angle. Now I'm going to look at C2 and my given angle B, and that's 165. So I'm going to have two triangles in this case. So I'm going to use the 180 rule of triangles for my A2. So I'm going to go down here, I'm going to put 115.8 in here. Now, A1 is equal to 180 minus 50 minus 64.3. So angle A1 is going to equal 65.7 degrees. Put that in my solution square. And then do the exact same thing for my second A2. So A2 equals 180 minus 50 minus my C2, which was 115.8. So A2 is going to equal 14.2 degrees. So it's a smaller angle, but that's all right. That means if you were out in the workforce or designing something and you needed these measurements in these specific spots, that you'd have to figure out which triangle it is that you wanted to use, because there's two possibilities. Okay, so now that we've got our A1 and C1, we can go find our little a, like our side A1, and same with our A2, using love signs. So everything goes back to normal, just two different situations. So A1 over sine of 65.7 equals 17 over the sine of 50. So that'll give us our A1. I'll just quickly rip out A2 here. We'll do the same thing. So A2 over the sine of 14.2 is equal to 17 over sine of 50. So A2 equals, all right, so A1 equals 20.2. Throw that in my solution square, 20.2. And then A2 equals 5.4. So there's a perfect example of ambiguous case triangles. Now I'm going to kind of box these off so you can put it on pause and see where everything is kind of connected. Okay, and right there. Okay, so there's kind of your multiple steps, but it's just repeated over and over and over, okay? So let's go look at the last one. Of course, we've done a triangle now where there was one triangle, a triangle where there was two triangles, and on the last one, we'll do a triangle where there's 0 triangles. So this one here, we'll kind of finish, and then we'll go back and we'll look at the the situation or the triangles to give you a hint on which ones might be ambiguous. Okay, there's a little something that we look at. So in this case here, we got corresponding side and angle. We're looking for an angle A using law of sine. So that means we can go and say B1, angle A1, B1. Same thing for the second one, B2, A2, and B2, just in case there's more than one triangle. We already know how many there's going to be because I said. So here we go. We've got sine A over 14 equals sine of 38 degrees over 8. So sine A equals 1.08. Now before we hit the second function on this, I want to take a breather and I want to go look at this unit circle again. So I'm going to erase everything here for a second. I'm just going to quickly rip through all this just like this so you can see something real close here. Okay, now remember we said cos is our x values and sine was our y values, right? So sine was our y values. If you look at our y values, you can see here it's 0, 1/2. This is sine now. So the decimal places you get when you do all that work. Root 2 over 2, root 3 over 2. And you notice here it's 1. And then over here it's 0. And down here it's -1. You can see from this that our unit circle is a radius equal to 1. So the biggest sine or cos could ever be is a 1 or magnitude 1 because you can have -1 as well. So when I flip back to this question and I get sine A is 1.08, once I know the unit circle enough, I should recognize that that's impossible. So when I go to my calculator and I inverse it, or second function sine, angle A comes up and it should give you an error or something like that. It doesn't exist. Does not exist. Right? So your A1 doesn't even exist. So if A1 doesn't exist, obviously A2 doesn't exist. Well, we're done. If you don't have an angle, a second angle, that means it doesn't happen. So there is no triangle in the world, in the universe, where this information, a 38 degrees across from an A and another side of 14, where it can happen. Okay? So ambiguous? Sure. Doesn't happen. So now let's look at a comparison of sides, because lots of people are like, well, how do you know if it's ambiguous? I told you earlier that I just don't even think about it. I just think about, do I start with the law of sines, finding an angle? And I just check each and every time. But if a person cared enough, if you look at your side and your angle and the other side, notice here, the side here is smaller than this side. Now, this isn't written in stone anywhere. If you look here, now, this side is smaller than this side as well. If you look here, this side is bigger than this angle here. So, on a triangle where there was only one triangle, the side opposite the angle you were given was bigger than the other angle or the other side. On the ambiguous cases, the side opposite the angle you were given was smaller than the other side, right? Just like in this one, the side opposite the angle you were given was smaller than the other angle. So, on an ambiguous case, the corresponding side that you get, the 17 and the 50, if it's smaller than the other side, possibly ambiguous. Because if your corresponding side is the bigger of the two sides, there's probably only going to be one triangle. Now, that's not written in stone, okay? but that's sort of a quick way to just say, oh, I got to really check this one out, okay? So that's pretty abstract, but that's probably the last lesson here for this situation. So good luck. I hope it makes some sense. I think that assignment's only got about 8 or 9 questions on it, so give her your best and ask any questions you got.